Hello everyone, my name is Tan Shet Ming and now I will present about the introduction. Industrial Building System (IBS) is a construction method or system that utilizes standardizing building components yet are mass-produced in a controlled environment. IBS has been initiated in Malaysia since 1960s when the Ministry Housing and Local Government visit a number of European countries to review their housing development plans. Following a successful visit in 1964, the Malaysian government embarked on a project to put the IBS to the test a year later, with the goal of reducing delivery times and constructing cheap and high-quality housing. The common components utilized in IBS project including panels, slabs, beam, staircase, and roof structures. These building components are usually being produced in a factory or at site factory under the strict quality control and minimum wet site activities. When IBS was implemented on site, the wastage issue could be reduced and the contractor could provide a good quality product to the customers. During the design stage for IBS, the design systems are set up to study the needs of the end users, marketing analysis, improvement of an establishment standard, as well as the layout of manufacturing and installation work. There are numerous mega projects that deploy the industrial building system in Malaysia, such as the Petronas Twin Towers, Bukit Jalil Sport Complex, and the Malaysian Light Rail Transit. However, this construction method had been introduced in Malaysia since nearly 4 decades ago, but its applications are still at low level. Thus, the improvement for this construction method is important in order to allow this method to grow in the future. There are 3 objectives in this project. The first objective is to evaluate the connection system used in the building from IBS perspective. The second objective is to determine the IBS score of the investigate building. And the third and last objective is to propose the suitable method of work to install and transport the IBS component. Now, I will present about the location of project. The building that selected for this project was the Shared Facility Library in Higher Education Hub in Pagoh, Johor. The location of this building was just off the Pagoh interchange on the North-South Expressway, and it only 20 minutes from the royal town of Muar, Johor. These shared facilities were shared among 4 institutions at EDU Hub Pagoh, which are University Tunku Hussein Onn Malaysia, International Islamic University Malaysia, the Southern Campus, University Technology Malaysia Research Centre, and the Polytechnic Tun Syed Nasir Syed Ismail. The shared facility library was built in 3 stories and covered 8,962 meters square with 1,500 seating capacity and can accommodate 50,000 student reference materials. The library also provides a wide range of amenities such as discussion rooms, meeting rooms, guest rooms, seminar rooms, multimedia rooms, career rooms, research rooms, and lockers. This library offers comfortable environment for the student to study in group, self-study, presentation, or relaxation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Putri Wana binti Kamaluddin. I will present my part, which is condenser system. Column 2 base condenser system for this project is grouted sleeve. This connection can be treated similarly to in situ connection because the bending joint and grouted sleeve are filled with grout. Dowel's bar can be pushed upward from the base or downward from the column in this case. Next, beam to column, the corbel. A corbel is a very short structural cantilever element that protrudes from a column or wall to transmit load. Corbels are placed monotonically with the wall and column supporting them in reinforced concrete construction. They are mostly found in precast structure including bridge, industrial buildings, and commercial buildings. For beam to column sliding plates typically have 20 to 30 mm of thickness. This plate protrudes from a beam inserted into a steel bolt anchor on a column. Lastly, column to column, grouted sleeve. This connection can be treated similarly to in situ connection because the bending joint and grouted sleeve are filled with grout. Dowel's bar can be pushed outward from the lower column or downward from the upper column in this case. That's all from me. Thank you.
Assalamualaikum dan selamat sejahtera. My name is Muhammad Fahmi Hassan. I will present about IBS score. Firstly, we need to consider the element of structure system. In the structure system, there's three components, which is ground floor, first floor, and second floor, and lastly roof. The total area of this construction project is 89,062 meters squared. And from the calculation, we get for part 1, IBS score is 43.75. Next element that need consider in IBS score is wall system. This is external wall using precast concrete and internal wall using masonry block. The total wall in construction is 789.29 meter. Based on the calculation, we get the IBS score is 16.1. Next, lastly, in IBS score, the element that need consider is either a simple construction solution, which is 80% of beam size follow the Mesa standard, 100% of column size, 60% wall size, 60% of slab size, 100% of door size, 10% of window size, and horizontal repetition of structure, uses of precast bathroom, uses of precast, and uses of beam model, and lastly uses of modular grade line. Based on this element, we get the IBS score at 31. The total in part 1, part 2, and part 3, the IBS score we get is 90.85 score, which is the highest score in IBS. Thank you.
So, Assalamualaikum and hi, my name is Putri Nushera. I will present about the method of work to install IBS component. So, the component can be mass produced and assembled in the factory under controlled circumstances, concurrently or prior to assemble on site using prefabrication and industrialized building system. This enables for sustainable shorter total construction period and early building occupancy, which saves time and money. Offsite prefabrication, on the other hand, demand greater coordination and planning through the design. Through concept of the setup process and on-site construction, the workload demand refer to the level of site fabrication, such as a product with volumetric modular system require less assemble on-site. Also, there is the need to plan about the machinery or equipment that will be needed on site for installation, such as crane to hoist the component into place. Another factor to consider is the installer capacity and competency in terms of their abilities, since they should be well educated to meet not only the major component of the operation, but also quality and safety concern. Component interrelationship are depicted in figure 3.1 below. The hybridization technology, which is a mix of tiny partial traditional technique and the mechanization technology, is the most ideal IBS technology for application in major building sector. In France and Denmark, as well as Hong Kong, the use of mechanization such as mobile concrete mixer and tower crane offer the best answer for high-rise residential structure. Offsite manufacturing, which occur at a large distance from the site, is now the most prevalent kind of production in Malaysia. figure 3.2 clearly illustrate the relationship. Next method of work to transport IBS component. IBS is a construction process that use factory-made building component that transport and construct into a structure using appropriate technology and equipment with a minimum of on-site people. Key factor causing construction delay in Malaysia are disruption in material delivery due to poor coordination and poor site management. In Malaysia, with a tropical environment and temperature ranging from 22 to 35 degrees Celsius, has distinct edge when it comes to implementing the open manufacturing plan. The open manufacturing system refers to firms that do not have a physical structure but do include heavy machinery, employees, a location to store raw material, and office. Worker, money, and plant are all part of traditional manufacturing system. The open manufacturing system for precast concrete is unusual in that it can produce natural curing concrete with a minimum grade of 30 in less than 24 hours and is well suited to tropical climate. A 10-ton mobile crane for 2 and 1 batching plant concrete are the machine employed by the IBS maker. To guarantee that the crane can readily install and transfer the material to the site, the significant value for each component of IBS precast concrete should not exceed 7 tons. Heavy-duty cranes are hard to come in Malaysia. This is because the transport radius of IBS component to site is limited to 50 km, and the major reason IBS maker decide to build half-size precast concrete is to improve erection effectiveness, make transportation to the construction site easier, and save money on crane hire.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Izzah binti Muhammad Nur, and I would like to proceed with the next presentation. So basically, this is the pillar table that I have created that consists of 8 references. This pillar table consists of facts, ideas, learning issues, and also actions. So basically, in general, I have covered on the connection system, Revit software, on top of transportation and installation, previous studies from other journals. Moving on to the conclusion, this review identified and discussed the 3 significant connection systems used in the Chart Facilities Library at HPTP Pagoh from IBS perspective by using Revit and AutoCAD software. Impressive IBS score has been obtained through every element, specification, and features from the building itself with 90.85 score in total. As for the suggestion on installation and transportation, having precast concrete in partial sizes that can be plug and play to form the scale precast concrete is suggested in order to achieve a smooth process in terms of time, effectiveness, and handling process. Despite the negative perspective concerning of IBS method, the construction player should really be convinced towards the technology adoption in our Malaysian industry, which in line with the Construction 4.0 Strategic Plan 2021-2025, it will be filled by 4 enablers, namely people, integrated technologies, economy, and governance in order to strive Malaysia towards embracing smart construction. That is all from us for this project presentation. Thank you for your time and attention. Assalamualaikum warahmatullahi wabarakatuh.